Our next session, we're going to return back to a focus on the U.S. government and federal agencies. This is Federal Agency Perspectives on Quantum. Our moderator for this session is Dr. Allan Bracker from the Naval Research Laboratory. Our additional panelists are Fredrik Fatemi from the Army Research Lab, Michael Hayduk from the Air Force Research Lab, and James Kushmerick from the National Institute of Standards and Technology, NIST. Please join me in welcoming Allan, Fredrik, Mike, and James.
Okay, welcome everybody. I'm Allan Bracker from the Naval Research Laboratory. I'm a research chemist and a section head there. So for this panel discussion, I'm going to be both a panelist and a light moderator. We have three other panelists with deep experience in research management and quantum policy. And so to start out, we're going to go with introductions and discuss some of the how quantum plays into the priorities of each institution in terms of technologies, research agendas, services, that kind of thing. So we'll start with Fredrik.
Yeah, Fredrik Fatemi. It's a pleasure to be here. I'm with the Army Research Lab. My job is a senior research scientist. In that role, I advise the Army in sort of investment strategy and research priorities, and also kind of educate quantum science to senior leaders. That's a pretty big, pretty important job, I think, for all of us. We have an emphasis, if you listen to John Burke's talk, there are four kind of key categories that we think about in clocks, sensing, computing, and communications, and networking. We go about these priorities and these research thrusts in a number of different ways. Internally to ARL, we have a pretty heavy emphasis on quantum sensing, but we have also efforts in clock development and networking. One of our key areas that we focus on is electromagnetic sensing using Rydberg atoms. It's something that we had demonstrated several years back. And then we have the Army Research Office, which focuses primarily on quantum, or focuses on all of these categories, but they also fund quantum computing. We don't do any of that work in-house. We have many engagements with universities. We have some partnerships internationally, and I'm sure we'll talk about some of this more as the session goes on. Quantum is exciting for all of us. I think it's an area that's not going to be fast, it's not going to be easy, and it's not going to be inexpensive. So a lot of the time that we think about at least in my agency and the DoD is long-term workforce development, managing expectations, looking at what's realistic and what isn't, and understanding that a lot of coordination is necessary to reach the end goal. Over.
Hi, good afternoon, everyone, and thank you to the organizers for the invite. This is just an event that just continues to grow and grow each year. It's very impressive, for sure. So I'm Mike Hayduk. I am the Deputy Director of the Information Directorate at Air Force Research Laboratory, or AFRL, one of the 9 technology directorates that comprise AFRL. So I help our director manage our overall scientific program in information technologies, which includes command and control, computing, communications, intelligence, and cyber technologies. Within that is our quantum program and one aspect of our quantum program. But in addition to that position, I also advise our AFRL quantum team and serve as a senior advisor to the team, similar to the way ARL or the Army is organized. We're grouped into 4 key areas: timing, sensing, computing and networking, and those areas are worked in 6 of our 9 technology directorates. So to give a little breakdown as to how we're organized, our timing group and our sensing group, much of that work happens at Space Vehicles Directorate. In Albuquerque, we also have some sensing work that's occurring at the Materials and Manufacturing Directorate. And that work is really focused in on quantum-assisted PNT, or how you'd be able to operate in the absence of a GPS signal. Our networking group is kind of split between Albuquerque, where we're doing ground to satellite communications, and then where I am in Rome, where we're doing ground to air, air to air type of quantum networking work. The work there is focused in on hybrid type of networking topologies. So multiple qubits, superconductors, trapped ions, and integrated photonics. And then on the computing side, we don't develop hardware in Rome per se. On our computing side, we're not developing a quantum computer at AFRL, but we're leveraging what's out there. So we have several industrial partners that I'm sure you've heard about that we work with, including IBM and INQ, looking at how quantum computing could ultimately be used as an advantage for the Air Force. Similar to what Fredrik said, we also have a basic Office of Research, Air Force Office of Scientific Research, international arms, 5 locations throughout the U.S. And then finally, the very much resonate with the partnerships piece, and I'm sure we'll talk a lot about that as we get into the panel. Over to Jim.
Yes, thank you for having us here. Jim Kushmerick, I'm the director of the Physical Measurement Laboratory at NIST. I'm the odd man out in the sense that I'm not part of the Department of Defense. But NIST sets the standards for measurements, precision measurements for commerce and research. So it's a fundamental role that we have. And because precision measurements are quantum measurements, we were early adopters, if you will. We had to kind of fulfill our mission. And we've had a formal program in quantum information science and technology for over 20 years. We run the full gamut of everything that's within the National Quantum Initiative, and what we really see is needed to build up a quantum ecosystem. This is from sensing, obviously, computing, networking, fundamental quantum science, and we actually have a bunch of efforts in enabling technologies, in cryogenics and in electronics control systems. As I said, the mission of NIST is to support innovation and industrial competitiveness, and we work closely with industry. So anyone here from industry, please reach out. We're non-regulatory. We have a lot of interactions, and we can kind of help guide you through measurement challenges. The QEDC, we set that up under the National Quantum Initiative. It's managed by SRI, but really led by industry, and that's another fabulous resource. And we're kind of in this international session at some level. And one of the unique parts about NIST is that we're the nation's U.S. National Metrology Institute. So we have an international mission. We work with other NMIs from around the world to set the standards for time and for the kilogram and for the meter. So we have to work on the international stage. And in this past March, there was a workshop in Paris, outside of Paris at the BIPM, but brought together all the different NMIs to say what measurements are going to be needed in the future to enable the kind of further progress. So this was called NMIQ, and there's a report that's out that if people are interested in looking at.
So at NRL and in the Navy, we anticipate taking advantage of the range of quantum technologies that are discussed at this Congress and by my fellow panelists. But there's a stronger emphasis on sensing. And so gravity, accelerometry, magnetic and electric fields, timing, we put that in a broad sensing category. Approaches involve atomic systems, semiconductors, which are an earlier stage of the research, the R&D process, and of course photons play a role throughout. And so quantum computing then is a topic of great interest as well, not on the hardware side, but on as end users, as quantum computer programmers, particularly in taking advantage of the possibilities in quantum chemistry and material science. And so my colleagues at NRL who work in that area are pursuing the possibility of doing quantum chemistry calculations related to ion transport in liquids, which is relevant to things like batteries and corrosion. In quantum networking, there's an effort in the broader Washington, D.C. area to bring federal agencies together in the so-called D.C. Quantum Network Consortium, which is a collaboration between those agencies, developing a quantum network testbed that's in development right now. NRL actually played a role in the founding of that effort. It involves the agencies of two of my fellow panelists today. So one theme that permeates the discussion at this Congress and in quantum in general is the significance of international interaction that comes with both great opportunities and challenges. And so I want to address that. What sort of and James already made some comments on that. What are some approaches and observations in that area? Maybe hear from Fredrik and Mike about the issue of international engagement. And if Jim has anything else he wants to add, that'd be it.
Yeah, I think I would say, first off, quantum technology advancement it's not a sort of field that advances because of a guy in a garage, like you have in the movies. And large-scale collaboration is really critical, and whether it's reaching across the globe or next door. So it's obviously a really important piece towards advancing quantum technologies. The way ARL approaches this, we have a couple of international offices on each continent and a couple of different countries. These are called the ITC offices that are run through the Army Research Office. We also, while it's not so easy to bring non-US citizens into our labs, we have many partnerships with universities and cooperative agreements with universities across the globe. And through those, we can bring in collaborators through these so-called extended sites that ARL has. And I'll leave it there for comments by Mike and Jim.
Yeah, sure. So I think I had alluded to earlier, we have Air Force Office of Scientific Research has several offices throughout the world. Their focus really is on to go work with universities, kind of do a lot of tech scouting, provide small seed grants. And that's really useful for us because it allows us, outreach into the world. And then, as that technology possibly matures, we're able to pull that in and start formalized collaborations within our technology directorates within AFRL. So that's one mechanism that we use. A second mechanism is maybe a larger scale, where we do Air Force to country or country to country type efforts through very formalized project agreements, which can take up to a couple of years to get up and running. But those are great because they really set a research agenda that both countries contribute to, that say the Air Force contributes and the Air Force and a partner country works on as well. So we have a number of those. We've started some in quantum. We're pursuing others that really allows us to go out and really partner and find the best talent that's out there to really ultimately accelerate the technology. And then finally, the third piece that we have started, we started this about 3 years ago now, 3 to 4 years ago, was our Innovari Advancement Center in Rome, New York, which is our open campus research area just outside our security perimeter. That allows us to really, we set it up for the sole purpose, or primary purpose at least, to partner internationally, to bring in international professors, small businesses, non-traditionals that may not have traditional cost accounting systems to work with the Air Force. That would be very difficult to work inside our fence line. It's been great for us. We have a number of partnerships that have come about from that, international students. And if that's something you'd like to learn more about, feel free to talk to me afterwards.
Yeah, so As I mentioned, NIST has an international role already because of the function as NMI, and we benefit from a lot of international collaborations. We have guest researchers from around the world that work in our laboratory, so we're able to have international guest researchers. But one of the real kind of force multipliers, if you will, has been our joint institutes. So with the University of Maryland and CU in Boulder, we embed NIST staff in the academic environment, in the university environment, where they're both interacting with students, both US and international students. So they're kind of have access to new ideas, which is always great. But it's also a workforce development at some level. There's many, many people in companies, a number of your companies and around the world, who have come through either NIST proper or through the joint institutes, have kind of learned measurement science, have kind of developed, and now are out there. And then one of the biggest successes, I would say, of international collaboration, you've heard about this a number of times already, is the post-quantum cryptography standards that have been released. They're the NIST standards, and we're very proud of them. But they weren't done in isolation. It wasn't just a bunch of NIST people in a dark room coming up with this. This was an international engagement, 8 years working with the best minds around the world to try to break these different prototype algorithms or these different, and really that's why we now have confidence that these will stand up to a quantum attack. So that way of working across the globe and pulling in the best minds is critical for the PQC, but also to really make a difference in this quantum system, because we've heard a number of times nobody has all the knowledge, all the workforce, all the pieces that we have to embrace this kind of in interactions with like-minded countries and things.
So I'll just mention a couple of examples from first or secondhand experience as a bench scientist, and then maybe a couple of broader things. Over the years I've been at NRL, we've had, I don't know, maybe a half dozen scientists from other countries come to work with us in our laboratories in the form of sabbaticals. As far as I recall, most of those were sort of ad hoc arrangements. One of them was through in the early 2000s, an agency that was willing to support a sabbatical, a US agency that was willing to support a sabbatical from a foreign scientist. Others have been through the university of the visiting scientists, so that was paid on their end. And those have been valuable. Those are collaborations that continued over a number of years, some of them actually still continuing. And then going the other direction, we just this year, in fact right now, we have one of my close colleagues is doing a sabbatical in Australia. NRL has a sabbatical program. There's quite a lot of bureaucratic overhead in making the arrangements, as he found out, but once it goes, it's a very enjoyable and productive process. And he's bringing back new ideas in the area of squeezed light generation, at the same time making connections with the group he's with in Australia that are probably very likely to continue. In fact, that group is funded by, I can't even remember if it's the US Air Force or Army, but it's a group that's quite interested in a lot of the same types of technologies that we are at NRL. And then more broadly, I should mention ONR Global, which fosters interactions between scientists at allied nations and U.S. scientists and the Navy, sort of work on Navy priorities. There are a few channels, funded channels that they use to do that. One is direct funding to the research groups in allied nations, where they stay in their own country and do research on Navy-relevant problems. There is a visiting scientist program that allows researchers to come and work with US Navy-funded groups here in the US. And then they also sponsor workshops and conferences around the world to generate interest and make connections in the areas that they care about. So finally, maybe go to a question that has, I'll make it short and somewhat open-ended. Maybe get a little bit controversial. And so the question is, what observations or concerns do you have about hype in the world of quantum science and technology? And see what...
Yeah, so it's, as I mentioned earlier, there's nothing fast, there's nothing inexpensive, and there's nothing easy about developing quantum technologies, and we're all excited about it. We're all, really, there's so many things that have excellent promise for not just the military or or commerce, but multi-use kind of technologies. And I'm often sort of in the seat where I am as an ST, to seeing sort of the at the very high levels, and it was mentioned in one of the previous sessions, there's not a lot of understanding of what quantum science is. And that is, it's an opportunity, but it's also a little bit of a danger, right? Because there might be a thinking that something is right around the corner when it isn't. So the way that I approach this is through try to give tutorials as often as possible to senior leadership. I think it's very important for the federal agencies to be coordinated in what we do and kind of have a unified voice. I think it's great, the partnerships that we have with academia as well, to bring in more expertise into the federal labs. As Jim and Mike mentioned, these partnerships, we also have a very strong partnership with the University of Maryland at College Park, and we're able to bring in kind of workforce that can help with this sort of education of the broader community of what the realistic timelines are for all things in quantum. One thing I'll say is that there's a lot of emphasis on things that are further out, quantum networking and quantum computing. These are absolutely outstanding areas. But one thing that can help is to highlight what successes we already have. And we have excellent successes in timing and in sensing. And while they don't always use entanglement, we can still use them as successes to say, hey, look, quantum has given us a lot of great things out there. GPS has a backbone that's based in quantum science. So that's one of the things that I'll mention.
Yeah, great. Probably not too much to add there, but completely, agree with the fact that, I think a lot of us spend a good portion of our time, educating our senior leadership, certainly in the Air Force, and I think the same would be true of the Army and the Navy. You get a lot of turnover in the senior leadership, as senior leaders, whether it's civilian side or military side, move on and upward. So you constantly have to reset that baseline, and technical education goes a long ways. It does the community no good when companies or academia comes in, tries to pitch something or sell something that's just not ready for prime time yet. With the Air Force or other services. So we have to definitely combat that and work hard to, really show, I think the best way to do that is show where we have successes. And timing and sensing is absolutely one of them. The advent of quantum sensing, I talked about the need for sensing and timing in GPS denied or contested environments, huge problem for the DoD. And we've made great progress. I think one cool thing was done a couple of years ago was the RIMPAC experiment. Ties in well with this panel on an international collaboration where we brought the Five Eyes together, the nations, along with Army, Navy, Air Force, took sensors out, took clocks out, traditional IMUs, did a lot of comparisons, back-end architectures, and really showed, all right, this is a good step at moving, quantum technology under development from the lab, large optical tables, out into very harsh environments. And I think those types of experiments, we should continue to do more and more of those while we balance the R&D that still needs to be done. But we definitely need to have those wins and show the successes where the technology is ready.
Yeah, I would just add on, or reinforce more than even add on, is that, so when the U.S. created the National Quantum Initiative, its tagline was a science-first approach, because it was realized that there was a lot of fundamental measurements, a lot of fundamental issues that had to be addressed. So, personally, I'm looking forward to the reauthorization of the NQI for another 5 years, but that same issue is still there. There's still a lot of fundamental it has to do. We're probably in the stage where we're starting to transition into an engineering aspect. How do we, we have some of the fundamental systems. How do we scale up? This is what you've been hearing from the companies. But there is the realistic timeline for people to understand that this isn't around the corner. This isn't, the next quarter for a financial kind of person. There's not going to be a huge investment. This is a lot of hard work, but the payoff is worth it. So as long as we're realistic. And John Burke mentioned the DARPA benchmarking program. I think that can go a long way to really understanding, and helping push these kind of devices further along, up the TRL level, if you want to call it that, or up the maturity level. So I think there's a lot of fabulous things that are done. I agree, celebrating our successes. There's a lot of successes there to celebrate. But just realizing that there are a lot of R&D that needs to be done before we get to, the end state, if you will, and that's not clear. And I don't think any of us are willing to say what year that end state would be, since we'd all be just completely doing a wag.
Yeah, exactly.
Thanks. So we've got several minutes left. I am going to move briefly to another topic myself, and I'm going to invite the panelists to make any concluding thoughts on just anything that they would like to say at this point. I'll just note that this has been a challenging last few years as far as workforce goes. It's been harder to find postdocs, harder to find potential permanent hires because of the strong job market, especially in quantum recently. And so, this last year, I turned to a number of internship programs at NRL. I was able to take advantage of one. It sort of kills two birds with one stone in the sense that we found a graduate student working in a very similar area. He was interested in working for us. We had a productive 2.5 months working at NRL. And so it actually helped us a little bit with our workforce issue, at least over a short period of time. We're actually going to bring him back for a few more weeks this winter. And at the same time, it's preparing the workforce for the future, which is another important workforce issue that's discussed.
Yeah, and just quickly, I'll say, again, quantum technology is a long-term goal, and we need to educate early, bring in through internship programs. Like I say, we do this with University of Maryland at College Park and other extended campuses. And it's not just sort of bringing in a new workforce, it's the handoff from the lab to an engineering center. That sort of side of the education is also very important.
Yeah, very, very similar. I know we're all in agreement on this, the importance of internship programs and growing our workforce and starting early. AFRL, we have a very strong internship program across, not only quantum, but all our other different disciplines. And I think as we look forward, especially, where I see it from my perspective in the Air Force, as we move technologies out into the field, it's going to become, increasing need for multidisciplinary types of involvement. Jim mentioned the engineering part of it. Certainly needs to be there. And the computing is, as the systems mature, the hardware matures, and we start bringing in, mathematicians, computer scientists who are working, more on the traditional HPC side on the quantum. I think that's going to be very key as well. So bringing all those different functions and different aspects together to really have a quantum smart workforce, hugely important to not only national security, but the U.S. as well.
Yeah, I mean, we somehow have to make it, attractive to go into science again. I don't know if it ever was, but there was the Kennedy space race, and there was this real call to arms, and we just don't have, and this is around the world. This isn't just the U.S., but figuring out how to do that, making it seem like it's the thing to do. I think would go towards that. And then finally, one last just plug for NIST in the sense is that, like I said, we're here. NIST exists to help industry succeed. Primarily U.S. industry, but most industry is global now. So if there's a measurement need, reach out. We usually have some answers for you, or we'd be happy to collaborate. So that's my final plug.
Okay, well, with that, we're out of time now, and I appreciate your interest, and I appreciate the contributions of the panel in this discussion. So thank you.